Okay, this is part 3 with logarithms. Again, we start out with the definition of a logarithm and some of the log rules over here. Definition of a log is that this b cannot be negative, cannot be 0, has to be positive, can't be 1. So these two things must be true of b. A has to be larger than 0. It can be a decimal, it can be a fraction, but it has to be positive and larger than 0. So the first slide I want to go to is the base change formula, log base 4 of 30. And you'll notice the base change formula right here says I can do this either as base 10 common log of 30 over base 10 common log of 4, or I can do it as natural log. Either way, you should come out with an approximate number here, 2.45. Anytime you need to, you stop and try these out on your calculator. You need to see these. Next one we're going to do is natural log of base 2 of 17. And again, natural log of 17 over natural log of 2. Well, you could also do this log since it's same base top and bottom of 17 and log of 2. Notice that's what I did up here also. Same thing. So if I put that into my calculator, and you should do that right now, you'll get an approximate number. These are rounded off. Logarithms are rounded off numbers. And here's one that's a little bit different. And you do want to try this one. This is log base 2 of x. To rewrite it, we would write it with base change. Over here's my base change. Write it log of x over log of 2. And when you look up log of 2, it'd be this number, 0.30103. And that's understood to be under a 1. So I could use my inverse button on my calculator, and that is the x to the negative 1 button. And if I hit that right after I do this log base 2, it will turn this into this. Now this is exactly the same number right here as this, but you have to divide this out, and that's what it gives you. This one throws some people off. Let's go to the next slide. Again, this is expanding. Now expansion is using these three rules on the bottom right here. Multiplication is turned into addition, and division is turned into subtraction, and the power comes out front. So I have all multiplication here, 5 times x cubed times y. So this would expand to log base 10. Notice the base was not determined here. It is base 10 then, times log of x cubed. And then we want to take care of this cubed here using this rule and pulling it out to the front. The power rule pulls it out to the front. So this would be an expanded log. The next one is verifying, and we're going to use expansion on that. I have these two things that's supposedly equal. Verify means maybe it is, maybe it isn't. You got to prove it. So I notice over here on the left, I have a 1 divided by 2. So that is this second rule, which is subtraction. So I take natural log of 1 minus natural log of 2. You'll notice that log base anything of 1 is always 0. That means this value right here is going to be a 0. I distribute the negative sign and get a positive, and so I've proven that these are true. So the next one we go to, again, condensing. This is an expand. Expansion means you go from this single log into a expanded log. Condensing means you go from an expanded log into a single log. So here's an example of an expanded log, we're going to expand this one because of the division rule here. We're going to turn it into a subtraction. Now the natural log base e of e, remember this is an understood base e if it doesn't have one there. Well, that would be the same up here as this rule. Log base b of b equals 1. This is going to turn into a 1. And then we're going to look up the natural log of 27 and subtract them, and we get negative 2.296. Had a little malfunction here. We're going to do this expansion up here. The natural log square root of 3x, and to emphasize this square root sign, is really a half power. So we bring this half power out to the front, which is power rule down here. And we notice this is a fraction, so that means I'm going to come over here to my subtraction rule right here, u over v. And so that expands into this solution right here. Okay, let's go to the next page. Solving. Now, I have solutions that go for probably another 35 to 40 problems, and I will do those in parts, but I'll walk through them real quickly with you. If you should pause when each problem comes up and try them, and then look and see what I've done. You don't learn how to do logarithms until you actually do them. It's like learning basketball watching TV. You don't learn much that way. You get entertained. So you'll notice here, I want to write these in base 2. If I write them in base 2, I don't have to use logarithms. So if the bases are equal, the exponents must be equal. So that tells me x equals 7. Here's another one. Try this one before you watch me do it. We can turn these both into a base 3. You see, 1/3 is really 3 to the negative 1 power. 81 can be changed into a base 3, also 3 to the 4th power. If the bases are equal, the exponents must be equal, so x equals negative 4. I didn't need logarithms for that one. This one is we're going to solve by adding the natural log of 3 to the other side. And then at this point we apply this law right here, this rule, which is the equality rule. Up here, base b equals base b. The two bases match. I'm base e and base e. So the antilogs are equal, since it's in both base e. So x equals 3. You see, that's the use of the log rules. Here's another one. E to the x equals 7. And this one takes advantage of the use of changing exponentials into logarithms. You see, we can't put 7 in an e to the something power. 7 doesn't have that. It has an uneven exponent. So we're going to convert this into a natural log, base e, which takes care of that e right there. And look it up on the calculator. Natural log of 7 is a very accurate answer. When you plug it into the calculator, you get a rounded answer. We round it off to 3 places. So here's 7 problems for you to practice on. The next part will be part 4. And hopefully this helps you to get practice doing logarithms. You learn to do logarithms by doing them. See you on the next one, part 4.